In today's lecture, we're going to be talking about loop design and certain characteristics of loops you need to pay attention to in order to make sure that your loops work properly, regardless of whether they're a for loop or a while loop. I'm going to begin today with a demonstration of designing a for loop, and then we're going to go through some of the different characteristics that I'd like you to pay attention to. So we're going to start by writing a loop that prints the odd integers 11 through 21 separated by spaces. And from last time when we talked about which type of loop you should choose, a for loop or a while loop, we said that if you knew how many times the loop should execute, then you should choose a for loop. In this case, you might argue, I'm not sure if it's 5 or 6. It's, the difference between 21 and 11 is 10. It could execute 5 times or 6 times. That's actually not relevant here. What's relevant is we know that we start at 11 and we end at 21. And we can have a way of incrementing our loop variable so that it increases by 2 each time. So let's just go to Code Light and see if we can't write such a loop. So we're going to want to start with I equals 11 because we're going from 11 to 21. And while I is less than or equal to 21, we want to continue our loop. Now, we're printing the odd integers only, so we want to skip over the even ones. And we can do that by adding 2 to I each time. That way we'd have 11, 13, 15, 17, and so on. And then all we have to do inside of our loop is to say cout the number. So in this case, I'm going to put a space first because they're separated by spaces, an I, and let's give that a whirl, see what happens. So we need to build it, and it says I was not declared. So let's go ahead and declare I. Notice I often do this. I develop my loops before I declare my variables, and then I declare them when I'm done. And you can see that it did produce the integers 11, 13, 15, 17, 19, and 21. And you could clean this up a little bit. It's a little annoying that there is a space between the first character and or a space at the beginning, and it's also kind of annoying that we didn't end with a line. There's things we can do. For example, to figure out whether it's the first one or not, we really don't want to print a space before the first one. We might say, for example, bool is first equals true, and then in here we could say if, say, not is first, or actually let's just say if is first. Okay, then we'll set is first to be false, and we will simply do nothing, else we will print a space. And then down here we could simply print I. So basically what's happening is if it's the first time we set is first to false, but we don't print out the space. Otherwise, we print the space. And now if I were to build it and run it, that did not look right. So let's do that again. And if you can see the problem, I forgot curly braces. So that was causing my loop to basically only execute this part of it, and the cout less than I was not getting executed, because I always say put your loop body between curly braces, and I violated that premise right there. Okay, so this time it works. We still don't have the end line, but we got rid of that annoying space before the 11. And before we end our program, if we simply add an end line right there after the for loop, that should take care of that problem. And now everything looks very nice. So there's, for the last time, our loop. And as you can see again, we initialized I to the beginning variable. We knew when it ended, it was at 21, and we incremented I by 2 each time. Well, let's move on. And here's the 4 things we need to look at. Terminating loop. Sometimes you need to use nested loops. We've talked about that once before. We'll talk about it, give you another example today. Then there's something called a break statement that allows you to get out of a loop early, and loop pitfalls, things you got to watch out for because they'll bite you if you're not careful. So critical things to get right in a loop to make sure that it terminates is you need to initialize your loop variables correctly. So that means in a for loop that you want your counter variable to be initialized correctly to the right starting value, and your ending value you need to make sure is set correctly. Notice that in my example where I went from 11 to 21 and printed the odd numbers, I was careful to initialize my counter variable, which was I, to be the correct starting value, and also I was careful to make sure that the value I tested I against was correct as well. If you don't do those things, you could end up with your loop not executing as many times as you want. You also want to make sure that when you're inside the loop that you make progress toward terminating the loop. In a for loop, that's done with the third expression in the for statement, and you simply, in this case, increment it by I. When I was doing my odd numbers, I incremented I by 2. So there's a number of ways to make sure that you terminate a loop. You may know in advance how many times the loop should execute, in which case you will be using a for loop, or you can, the last 3, 2, 3, and 4, all involve using a while loop. The obvious thing is to ask before iterating again. So at the bottom of the loop, say, do you want to do another calculation? And if the answer is no, you exit. Another technique you've seen thus far is that we'll give you a sentinel value, which is a value that the data cannot legitimately assume, such as miles driven being a negative number. And as soon as you see a negative number, you exit the loop. And again, that would typically be read right at the bottom of the loop. And finally, this is a technique you won't see until a little later in the semester, but sometimes we'll just keep reading the input until it's exhausted. There's no more input to read. Like we're reading all the students at UT, and when we're done reading all the students, we want to stop. And it turns out that CN will set, or the system will set a variable in CN that you can test to determine whether the input has been exhausted. But we'll cover that later once we get to chapter 6 of the book. So we're going to revisit nested loops now. Just again, it helps to sometimes repeat things. You've seen it once before, but we're going to do it again in a slightly different context. So my problem is I have some students. The first item on the line is the student's ID. So 48685 is my student's ID. And then we have 3 test scores. And we want to print the student's test score, average test score. But we also want to repeat the computation for every student that we read. So in this case, we want to repeat the computation 3 times, and then we're going to use a sentinel value -1 to indicate that we've exhausted our input. So this actually requires us to write a program that has a nested loop. The inner loop is going to be a for statement that processes a line of input, or in this case, a student's grades, and computes an average. And then the while loop is going to be the one that is the outer loop and reads each line until we get to the -1. I often find it easiest when I'm designing loops to write the inner loop first and test it. So that's what I'm going to do here. I'm going to assume that I've already managed to read the student's ID. We'll take care of that when we write the outer loop. And I'm just going to concentrate on calculating the student's average exam score. So I'm going to need to keep track of a running sum of the student's exam scores, hence the sum variable, and I need to initialize it to 0. And then I know that I have 3 exams, so my counter variable, I can start by initializing it to 1, and I'm going to continue until I've read 3 exams, and I'll just increment my exam by 1 each time. Then my loop body involves reading an exam score and adding that exam score to sum. When I'm done with this for loop, I've read 3 exam scores and added them to sum, so I can print out the student's average score by dividing sum by 3. And I decided that to line up my output nicely, I was going to use a tab character, so that basically when you have the output, if you could see it, it might be like 4845 and a tab, 87.5, another one, and a tab. So tabs just have a way of lining things up nicely, hence that's why I put the tab right there. So this gets me my inner loop, but now I need to also add the outer loop that's going to read student IDs, and it's going to stop when the ID is equal to -1. So this is our familiar friend, the priming read. We need to first read an ID before we try to enter our loop, because if there's no students, we'd never want to be in that loop to begin with. So if the ID is not equal to -1, so if it's anything legit, then we will do the code that you saw just a moment ago. This is our inner loop code for calculating the average for a student. And once we're done computing the average for the student, we're ready for the next student. So sometimes we get comments, when is a good time for a comment? Well, this probably is a good time for a comment, which would be read the ID for the next student. So we know that we're setting up for the next student. We'd probably also put here a comment about how we're computing the average exam score for a student. Okay, so here, this read down here reads the ID for the next student. Notice how if the next ID is -1, when we come up to the top right here, we'll end up exiting the loop. Okay, so the next topic to talk about in designing loops are break statements. Break statements are a bit like panic statements. It says, let's get out of here immediately. Something's gone wrong, and we don't want to be in this loop anymore. Now, sometimes it turns out something's gone right. We found something earlier than we expected, and we also want to get out of the loop. But the bottom line is the break statement provides a nice way for us to get out of a loop early. So here's an example. Let's say I want to sum the first 10 numbers that I read, but if I get a negative number, I want to get out of the loop. I don't want to read all 10 numbers. So here's 2 sample inputs. The first has 10 positive numbers, and my output would be to say the sum of 10 numbers is 15. Well, that's not right. It's actually 55. But the second one has a -4 embedded in it. So in this loop, I want to get out early, and just print the sum of three numbers is 6. So my output should be the number of numbers that I summed and their sum. So here's our first try at it. We want to get out early if the number is negative. So I've declared a Boolean variable called number is positive. And if the number I read is less than 0, I'm setting number is positive to be false. So that will give me a way to test in my for loop whether I read a negative number. So up here, not only do I ask if I is less than 10, I also say I can only continue if the number is positive. So if I is 10 and the number is positive, I will read another number. But if you look at my output, it's not right when I do it with a negative number. I get the sum of four numbers is 2. So there's two things wrong here. First of all, I summed four numbers, not 3. And clearly what happened is I subtracted the 4 from the sum of the first three numbers because 6 minus 4 is 2. So what went wrong? This is often, now you could put in print statements, but this program is sufficiently simple that you can actually trace it out. What happened was that even though the number was less than 0, we still ended up adding the number to sum, and that wasn't right. So we could start fixing the problem by saying else. So we only want to sum the number if it is greater than 0. So that could be our first fix. But that still wouldn't solve the problem that I, right down here when we printed out the sum of I numbers, well, I was one too big, it was 4. And the only real way to fix that is down here, I have to say if number is, if number is positive equals false, then I decrement I. And you really should get comfortable with using the not operator, so it's really the same as saying if not number positive, I minus minus. But this obviously is pretty complicated, not too easy to read. So a better way to do it is to use the break statement where I can get out fast. So here I have done exactly that. Now I have a very nice for loop. I just assume the input's good. I go from 0 up to 10, incrementing I by 1. I read my number, and now if the number is less than 0, I break. I get out of my loop. So the break statement is just break followed by a semicolon, and it says get out of the loop. So if I ever encounter a number that's less than 0, I prematurely exit the loop. And as you can see over here, with an input of 1, 2, 3, and minus 4, I get the right answer. Okay, so break's a handy tool that you may decide you like to use. Some of you may have noticed, or you may not have, I could have avoided the whole problem by using a priming read. I think this code is less intuitive. You might disagree. You decide. This all has to do, remember the lecture is loop design. There's no one perfect way to do it. You have to decide what you're comfortable with. But at any rate, I could have read the number before, my first number before the loop, used a priming read. And now I would check both is I less than 10 and the number greater than 0. If it's not, I don't continue. And I only come into the loop if the number is greater than 0 and add it to sum, and then I read my next number. So if my next number is a negative number, this condition will be false. and the loop body will also exit. Again, you decide what you like the best and go with it. Okay, so here's one where I haven't shown you the break statement. This is a more positive example where the user inputs a value and I'm trying to figure out what it is. So I run a loop from x equals 0 up to 20 because I assume the user has entered a value between 0 and 20. If I find it, then I want to get out. So I don't want to continue. So down here I said put my comparison between x and y here. So if x is equal to y, I want to get out of the loop. So if x equals y, break. So there's no reason to continue if we found what the value of y is. Let's say the value of y was 3. Well, once we find x, once we set x to 3 and determine that it's equal to y, there's no reason to keep going any further. We might as just well as quit early. So that's the idea. Okay, so the final lecture topic is pitfalls of loops that you should be aware of. The first one we've talked about a little bit before. It's the infinite loop. We have to make sure that our condition for continuing the loop eventually becomes false, and that means trying to make some progress in the loop. So here I'm saying while x is greater than 10, add x to the sum and print out the sum. But notice I forgot to read another value for x. So it means I get stuck like the movie Groundhog. I'm never going to be able to get out of here because whatever value I read for x, say 25, it's just going to still be that same value. In fact, if I go to Code Light and I have it right here, here's our loop, and if I run it, I'm going to enter a value of 25. Actually, need to make this thing the current project. And if I run it, I'm going to enter 25 for x and see how I'm just getting an infinite loop. It's just never going to stop. So, and it may look like, how come it started so high, but it didn't. Actually, way back it started at 25. It's just the computer is very fast at how fast it does its computation. So it just never got out of there. To fix it, of course, what I could simply do is add a read. So I'd read the next value for x. And if I now run it and build it and run it, 25, 15, 40, now I'll enter 5, that's not greater than 10, and I exited my loop just fine. So make sure you make progress toward terminating your loops, or else you'll get an infinite loop. The next thing is, don't put semicolons right after your for statement, because if you do that, it immediately terminates the loop, and nothing, it says the loop body's empty. So in this case, you think you're printing hello 10 times, but you actually will print it only once because it's outside the loop. So if I go here to Code Light, now I'll just replace what I had with count. And I need to declare it. And you can declare your variables in a loop like this. You can declare it in the loop body, that's fine. So I will do so. Get an unexpected error down here, so I take a look. Indeed, I don't, this curly brace right here is not matched. That's my problem. Okay, and you can see I have my semicolon right there, so if I build it and if I run it, instead of printing hello 10 times, it printed it once. Okay, there it is. Now, you could have fixed this problem, well, or seen this problem if you just use the source code formatter. Notice how it Code Light knows that this isn't right. It moves the C out back, and that would also tell you something's wrong with the for loop. Okay. I also said that this int right here, I could declare it there as opposed to, say, declaring it here. And the difference is that count only will be, if I declare it here, count is only visible, or should only be visible, inside the loop. Outside the loop, I can't count on it being visible. So for example, if I tried to have cout count right here, there's a chance with some compilers that that count will be undefined. See, error name lookup of count changed using obsolete binding at count. So what it's saying is that I declared it inside the loop. It only existed inside the loop. Now I'm outside the loop. Count right here is undefined. Okay, and our final problem is off by 1 errors with loops. So it happens a lot. For example, here's a for loop where I want to sum the numbers from 1 to 10, but I said I less than 10 rather than I less than or equal to 10. The result was I only added the numbers from 1 to 9. So I could have fixed it either by saying, well, that would have been the best way to fix it. And that would have now made sure I summed the numbers from 1 to 10. So be careful about your off by 1 errors.